Alright, in the previous lecture we were studying about what ground based platforms are. So we already had discussed that these are either handheld cameras, cranes, ground vehicles, tethered balloons or even towers. And then we also understood that these are relatively inexpensive, right? The satellites may be very expensive, these are stable. They provide high resolution data. You get a very high resolution data when you are taking photographs or images from a lower altitude. Okay. The other one is airborne platforms. Airborne platforms are those which are up to 50 kilometers in altitude. Okay. So we can use various airplanes, helicopters, unmanned aerial systems or high altitude aircrafts for this. Then comes the spaceborne platforms. So the major platforms which are being used for remote sensing are space-based or spaceborne platforms only. While doing photogeology, you had taken the remote sensing images or the panchromatic images which have been taken through the airborne platforms. We will study in detail about the spaceborne platforms, yeah. So space-based platforms, they include space stations as well as both low-level and high-level satellites. That is within the altitude of 700 to 1500 kilometers and approximately 3600 kilometers. So these sensors which are present in the platforms, present in the space, they can acquire data of very large areas. Okay. You must have seen that how during Pokhran test, the temporal data of a satellite helped the people who were doing this Pokhran test out there, because the satellite has a time of reoccurrence. So it used to come at the same spot after 8 hours. This defines the temporal resolution of the data which we are getting from space. Likewise, there is a spatial resolution of the data. Nearer is the sensor to the surface of the earth, the better will be the resolution. Alright. Farther it is from the surface of the earth, the resolution reduces. So what we have to do, we use various sensors which give better resolutions to us. Better will be the resolutions, better will be our interpretation then. Okay. We will understand about these characteristics of sensors in the next unit. So these space-based platforms, they can have polar orbit at an inclination about 80 to 100 degree as it is shown here, parallel to the poles. So they take approximately 90 minutes to complete an orbit, and then they are placed in at about 600 kilometers to 1000 kilometers altitude, and they give a global coverage of the earth to us. They cannot provide continuous viewing of one location although. Okay. Coming to the sun synchronous orbit. The orbits which are synchronous to the orbit of sun. So the sun synchronous orbits, as it is shown in the figure here, they pass over any given point on the earth's surface at the same local solar time. So this satellite passes over the same location at the same time always. Okay. So they cover a constant local time of the day. So at a given altitude, these satellites, they pass overhead of a particular same location, and then they can also give us various data in different seasons also. So these are helpful in that way. And they have they are put at an altitude of around 700 to 850 kilometers, and they take around 90 to 100 minutes to take an orbit. So they take around 14 orbits, so they have a good temporal resolution also. And then the images that we get, they are better in terms of illumination conditions also. Next, coming to the geostationary orbits. Geo, Earth, stationary, being static. So these orbits are located at around 3600 kilometers above the equator at an inclination of 0 degree. Okay, parallel to the equator. The orbit is parallel to the equator. The orbital period of the satellite is equal to the rotational period of the Earth. So what the result is that the satellite is fixed position relative to the Earth. Okay, so these are positioned at different longitudes in order to increase global coverage. So we have various geostationary satellites which give us the data of particular locations at a time. They make repeated observation over a given area only. So this has this orbit, the other one will have another orbit, the another geostationary satellite will have another orbit. So all these will be at an inclination of 0 degree to the equator, and then they will study a particular area only. So they give high temporal resolution also. Okay. So we studied about various platforms, what platforms are, how many types they are, the ground based, the airborne and the space borne platform, and within the space borne platform we studied about the polar orbit, the geostationary orbit and the sun synchronous orbits which are taken by various satellites, and on the basis of these locations, these orbits, we get different types of data. Okay. And what else did we studied? We studied about various ranges of the ground based system also, and the ranges at which the airborne platforms can be used, and also the space based platforms they can be used. Okay, thank you very much. So you please feel free to ask any questions.